let's start doing some cool stuff with plotting. So for this week, indeed, the idea is that we will kind of dive into doing visualizations in Python. And we will introduce you one package that is quite, well, it's kind of a grand old man of visualization in Python called Matplotlib. And we will kind of get practice on how to do visualization in those, using those tools that the package has. So basically the learning goals for this week is that, well, we will do quite simple things and kind of use the knowledge that we have gained this far doing the data analysis. So we'll use again real data and then try to visualize that. Actually, you have plenty of it might be a good thing or a confusing thing because there are different packages that can do visualizations. They have like a bit different approaches. They can do a bit different kind of visualizations, and that's kind of how it is. But what I recommend you to do is that whenever diving into the visualization world, kind of try to understand one library first, and then you kind of know a bit more about how that library works. Then do the next one. What we are starting with now is this map package, as I said. But then there are really useful packages, plotting, for example. Okay, this is kind of a nice plotting library that can be used for doing interactive plots and so on. Then there is Matplotlib, which is another library, especially in our web-based visualizations that are interactive, so that you can interact with your game and so on. That's also a good one. Then there is Dash, which is a Python framework for doing these kind of dashboard applications. It's also really good and nice. It kind of uses the web front-end development framework for React and Mongo. So it's very nice package, but complicated than what we have heard now. And then there is these column views and geo-views that are good to packages as well. Maybe I can quickly show you a couple of examples. For example, these kind of interactive visualizations with this amount of code. So let's say, I don't know, is there even 10 lines of code in this, and we will use this visualization. So try in different countries, and you can basically select so they are really kind of advanced and efficient packages available to use for doing really nice visualizations. And visualizations are really important in many ways. When exploring your data, it's really important that you not only make good calculate needs and structure, but also kind of visualize how to so that you can understand long but before starting, so let me quickly take a look at the kind of anatomy of the plot. There are, of course, well, 10 stories you can take a look at, there are links to each of these plots, so you can take a look at how do they actually look like, and they are quite good. But to begin with, maybe to take a quick look. Well, maybe this is. Can you see it? Okay, but this is kind of a short introduction to different kind of elements that we have. So this is a typical line of monthly observations in here, and then you have on the y-axis some kind of proportion. So this is a social media post in one national park. So there are a few things that kind of what makes a plot. So typically you have two axes, so you have x-axis, such as here we have the month, and y-axis, which is some values that you want to plot against this other axis. Then in this case we have the lines here that represents the observations and the values that you have. In this case we have actually two lines, and what we they are colored with different colors. Then we also kind of have a filling between those lines, so to kind of demonstrate the difference between these two lines here. Then what these things are called, they are ticks labels. So whenever you are kind of searching how to format these ticks, make the font size larger or whatever, using this keyword when googling like format tick labels. So you will find a lot of the materials. This is called X label, and this is Y label here. Also already find for title, this is in here, and you might have some annotation, for example here the highest speed that has been added, and you can also reload. Solid line cache. So that's a kind of a quick introduction what a plot typically is. Of course, in different kind of plots you have different kind of elements and so on, but these are quite typical. Then, but let's actually dive in to the. Do I have this? This is the exercise. basically first how we can, well, so I don't need to do that. So there are two ways. So the ones who are doing the NumPy thing, so there's a bit different way how you can bring the data using NumPy. They are quite similar in Pandas and NumPy, but basically in NumPy we use this gen from text function, and we specify the bypath. We skip the header, so we skip the 9 first row, and then we specify the delete comma. And with this, we should be able to have the data in. Let's see if we got some values in here. Yes, we have some arrays of values here. So we kind of are good to go with the NumPy stuff. In Pandas, the same thing. This is now maybe good to see the ones from Pandas students and NumPy students, so how we do these things in different libraries. So in Pandas, the same thing is quite similar. We have this function read CSV, and there we basically specify the file path, and we skip 8 rows. So here we specify basically the row. This is basically, we don't want to have the column names, but we want to have the column names in Pandas. So there are a bit of differences in NumPy and Pandas in that sense that Pandas isn't working with kind of spreadsheet kind of things. So we have column names for Pandas in NumPy typically. Then what we want to do is that we want to kind of extract certain columns from the Pandas data frame. So we want to take the date, temperature, maps. Why we are doing this now is that we want to harmonize how we actually are kind of teaching the plotting things. There are other ways how we can plot using Pandas. Kind of see how we can do plotting quite similar approaches, whether you can use Pandas or okay. So let's do our first plot. So what we have now is that we have some information about the dates. We have some temperatures. Let's do a quick look at dates. So as you can see, we have an array of values from that column here. So that temperature maximum values as well. So we have the values, and they come from the Pandas data frame now. But exactly the same values we have here in data. So let's do our first plot. It's actually fairly straightforward and easy to get started with. So we want to create a line where we have some x and y values. So let's specify that the x value of our plot is the day. So we have some day on the x-axis, and let's also specify that on the y-axis we have temperature. So x is day and y is temperature. That's what these are. Then how do we actually create a plot? So it's quite straightforward. The easiest way how you can start with this is that specify each date as text value. So when we execute this, what will happen is that we actually get our first block. So now on the x-axis we have days, and they are basically these kind of numbers running. And then on the y-axis we have temperature, these are our bar files. But basically we got pretty nice looking figure already. It is really wonderful. So, did someone, are you following? Did someone have a question? Good. So, now we kind of got an understanding how we can create this kind of simple blocks, but it doesn't look as nice as it should. So, let's see how we can start modifying this. First of all, let's see that I'm not really a fan of this line in here. So let's see that if we could modify that a bit in a way that we change the color, that we change the style line to make it more even. So let's do the same with the same blocking function. adding a title into your plot. So let's add a title to our visualization and say that we have what these are. So they are cupola temperatures in June 2016. And when executing this, we get a nice title added on top of our plot, and that's good. Let's still add the X label and the Y label so that people who are reading this visualization can actually understand what these values are representing. So adding X label is as simple as specifying PLT.X label, and then you just specify with the string what do you want to have as the label. So when doing this, we added this date label in here, and in a similar manner we can add the Y label, and let's add that as temperature. Well, I do it now like this, Fahrenheit, and then we get a nice Y label into our visualization. So they are kind of a pretty simple steps and functions that you can use to modify the appearance of your plot. So from this one, we didn't need to do much, that we actually got quite much nicer looking visualization in here. So that's kind of a good thing. Is there any questions at this point? Does it seem, I think this should be fairly straightforward. Of course, you start doing yourself, always some peculiarity is coming. Yes? These are basically because the numbers that we have. Let's take a look at the date. So the numbers that we have are these kind of 2016 blah blah blah, so it's kind of just shortens those. So this is how do you call it in English? Yeah. So that's what it is. Good. There is a. So let's. Is there some other questions? No. Let's continue. There is a nice way how we can actually make our figure bigger. This is something, well, I don't use this so often, but it's nice. So it basically specifies the default size of the figures that we're plotting. So using these RC parameters, we can specify different default values for example, this figure size. Do you want your turn already? Yeah, so inside here, what you specify as kind of a value into this parameter here is that you specify the width and the height of the plot, and these are by default, I guess, inches, right? Yeah. So by default they are in inches specified in here. So just executing this, we basically should have the figures coming in with this size. Yeah. And ta-da! Now what we have in here is that we have a little bit bigger plot here.
So the reason it's nice to add that one command in here is like I often do this with the all plot. I think often that you're trying to make a certain figure one down individually on a plot by plot basis, how big the one is. This just sets the default size is larger than
Yeah. Then let's take a look a bit more. So let's see how we can actually annotate some text into our figure. So what we're going to do next is that we want to add some text in here saying that, well, we want to say that there is a high temperature in early June, which is something around here, this area, the x-axis. So let's take a look. So with this function plt.text, it's possible basically to but with this one, you basically what you want to specify is that you specify the location where you want to add that text. So this is basically the 2016 June the 4th. So this is the location that at this point in our plot on x-axis annotate this text, and on y-axis it should be on the Fahrenheit 68. So if running this, here we are. Perfect. So maybe I just here we can now see, again, we have the same data here, but we modified the values or the visualization quite a bit. So what we actually did in here are, well, we have the original plot that we had, and we specified the labels, but then what we did in here was that we, let's first do it like this, so let's do one thing at a time. So first of all, what we do here is that we indeed annotate. So we add this text into this location, and the location is specified with this x and y coordinates that are based on the data value we have in our plot. And then the last argument is the run text that we want to add. Then what this function here, pld.x is. So this is kind of specifying the limits to our data. So it is possible to basically control that, for example, show only the dates between, what do we have in here? So dates between the 1st of June up to 15th of June. So you can basically specify the x-axis limits for your data, so data limits, and then you can also specify the same things for y-axis. So what this will do is that it will kind of control what is visible for the user by specifying the kind of ranges for x and y values. And when we execute this is exactly what we will see. So now we have only x values ranging from the 1st of June up to 15, and then the y-axis we have the Fahrenheit ranging from 55 up to 7. So this can be quite handy function to actually specify and kind of limit the area that you want to show the person who is looking at your figure. Of course, these kind of line plots are not the only kind of plots that are available. So we can also do, for example, bar plots. But before I go here, is there actually a question about I guess you will kind of explore yourself these functionalities. So in the practical sessions you can have assistance if there are some things. that are confusing. But yes, so let's do another kind of plot. So let's create a bar plot in Matplotlib, and it is as simple as creating a ball, a bar. So it is done in a similar manner as with the line plot that is by default pld.plot, and that is how you can do it. But pld.bar is kind of a function that we can use to create a bar plot. And bars in our visualization, and the kind of height of the bar tells about the data distribution we have in here. And still we have the annotation in here. So all the same functionalities that you saw working with the line plot are still available in here. So the only thing that we actually adjusted was just that we changed the kind of visualization form that we have. So to try out different kind of ways how you want to visualize. Of course, what is the correct kind of visualization type? It depends on many things. For me, I always try to kind of keep the visualizations in a way that they are as informative and easily understandable as possible. And for those things, it depends on your question and data what kind of visualization works the best. But yeah, so now we have seen a couple of different types of visualization, but of course these are now on these notebooks, but typically you want to save those visualizations that you do into a file. So for example, you can automate the visualization processes quite easily. For example, if you would like to, well, in the exercise we are actually plotting separate plots for each year, so you can basically loop over different years, do the data analysis, and then plot a nice figure out of those. So these kind of things are where the programming actually gets the really powerful. So how we can save a figure? What do we have in here? Yeah. So yeah. So what do we have in here is that we have this kind of visualization, and if we want to save the figure, it's fairly straightforward as well. So we have basically first these kind of plotting arguments that we use to change the aesthetics of the figure at the title, labels, text, and also limit the axes, so the data ranges. But when we want to save this figure, is that there's this pld.save fig. So again, pretty intuitive function. So what this will do is that it will save the figure into a disk, and what you specify inside is the name of the file that will be saved. So what I use typically is that I specify the name, and then I specify what file format should it be. And the PNG file is the one that I quite often use myself. And when we execute this, and I guess we need to refresh this. No, we are on the... Yeah, actually I was in the wrong folder. But when I executed this, it did the visualization, but in addition it actually created this PNG file. And well, it's the visualization that we saw. So quite easy way to actually save your figures as well with this .save fig as well. You can change the file format really easily. You can just change the name, for example, GVEC format, and what it does is that this refresh here. So now we got, well, the same figure but in different formats, and it actually should work also with, if you want to save the PDF. The same thing works. Now, maybe this cannot show the PDF, but basically it will create and generate a PDF file out of your. I did, but somehow might be that this environment doesn't know how to. Yeah, but if you would do this on your own computer, yeah. So maybe these are kind of the really introductory parts in plotting with Matplotlib. Soon they will show you some more tricks and things that you can do with Matplotlib. But maybe just a final note. So typically how Dave and I both are doing visualizations is that, of course, we are reusing the codes that we have written ourselves, but how we have originally written those codes that produce visualizations. So quite often it's beneficial if you take a look at the gallery of this works. Yes. So for example, Matplotlib, so it has really good documentation and it has really nice gallery of different kind of visualizations that you can do and use. So this is always a good starting place when kind of seeing that, for example, if I want to do this kind of, well, this is a violin plot that I mentioned. So if I would be interested in creating this kind of violin plot, so it's a good place to start by taking a look at these examples that are available on the Matplotlib web page. So we recommend for you to kind of take a look what are available in here. There is tens of different kind of visualizations in here. So it's kind of a good place to see and get understanding what is possible to do.
Yeah, I mean, I guess are we going to have coffee break?
Yes.
So maybe if you want, during the break, you could even go to the Matplotlib gallery and click on one of the plots and you just copy and paste the text. The code for how to shoot that plot into the computer lab, into a Python file there, you can be able to run it and get the plot.
Yeah. Yeah, these examples in the gallery, they are always done, I think they are always done in a way that they are kind of just generating some data on the fly, so you should really be able just to copy and paste and reproduce. Good, but maybe we have a break at this point. If you have any questions, so you can, well, come and ask, but otherwise let's continue 20 to 11, so we have time to do some more advanced plotting.